Yeah. Okay. Start. Okay. So can everyone hear me? If you can hear me, just type in the chat or something that you can hear me, so I can start the presentation. Yep. Okay. Thank you, Sheila. Welcome everyone to today's lecture on building information modeling and passive design. So my name is Islam Mashali. I'm a postdoc here in UQ. Just started 2 weeks ago, and I've just finished my PhD a few months ago from QUT. My topic was around like parametric design and computational modeling, and using passive design and daylighting design. And I've been using Grasshopper and Dynamo and other tools such as BIM Tools, Revit, and other tools that we're going to be talking about today. So today's presentation is about that topic: building information modeling and passive design. So let's start the presentation. Okay. Yeah. So today's content will be we'll be talking about what is BIM, what is the definition of building information modeling, which is pretty related to the workshop that you're having at the moment. It's part of the bigger picture of what we're doing and what we're trying to achieve in such a workshop. And we're going to talk a little bit about some of the BIM applications and BIM tools that we use, and how BIM and sustainable design are related together and how they come together, and how it's been applied in such a design process, the passive design process. And we have some case studies that we'll be sharing with you today. Okay. So please feel free to ask me any questions in the chat, and I'll be posing at any time and look at those questions and reply to them. Okay, so first of all, let's start with what is BIM, or what is the definition of BIM. If you can type in the chat box if you already know what is BIM. I just want to know like what's your level of knowledge about BIM, and so I can go into details, or maybe have a more of a laid-back definition for you to start understanding what is BIM. So if you know what is BIM or you don't know, just type into the chat box what's your level of knowledge about that topic. So we can, until you start typing, I can start with the the basic definition of what is BIM. So BIM stands for either building information modeling or building information management. It can go both ways, and they're actually both interchangeable definitions for the word BIM or BIM. Depends on the country that you're in. Sometimes they call it BIM, sometimes they call it BIM. It's a synonym for that. So BIM is basically it's a process. It's not just a tool; it's more of a process, a holistic process for the design of a certain building or a certain project that you have, construction project. So it starts from the programming phase of the project up until the conceptual and detailed design, and you can do analysis, different types of analysis for the design that you have, and it goes through the documentation, fabrication of the different elements of the building, and then through the construction phase, and later on when you finish the building, you can use that model or this process in operating and maintaining the building, and either you can use it afterwards in demolition or in renovation of your building. So it's a process for managing and planning designing buildings and managing buildings and different infrastructure. So there is a saying that goes, like that. Information is the oil of the 21st century. So information is more of a commodity, a valuable commodity for us, and it's really important to know how to manage this information efficiently to perform the required tasks and action, and utilize the information in the best way possible to get the best outcome of the information that you have. So in a laid back definition of BIM, just imagine that a certain project will have different stakeholders and different designers, like the architects, the structural engineer, mechanical engineer, and they all have their own part of the project and their own like designs and plans and different documents that they use in the project, and they want to transfer those information between the different stakeholders in a way that's efficient. So the old like traditional way of doing that in the past maybe 50 years or something, it was through CAD files and comparing those CAD files and making sure they're updated using manual manual work and making sure that those are updated manually. However, with the rise of technology and having more faster processes and better storages and cloud-based systems, we can now use a centralized model, which is what we call the BIM model, to operate the design process and to make sure that the design process is synchronized, and we can extract information from different different stakeholders and make sure that they're synchronized and it can be exchanged to support decision-making process regarding the building or a building asset within the model. So this is a very interesting graph. You can see in the last 10 years, only 10 years, and how the BIM adoption has gone throughout different parts of the world. So this is this information comes from something we call the NBS BIM report. I guess that was the National BIM Standard report. So it consists of different countries like UK, US, some countries in Europe, and even Australia. And this is a survey that has been done in some of the big companies there. So you can see at 2011, only 13% were adopting BIM processes within their design process, and 45% were just aware they were not adopting that, and around 43% were neither aware or using what we call the BIM process, as we know at the moment. And you can see throughout the years, this percentage has increased up until just 1% are not aware, or less than 1%, and around 73% of those same companies through the survey that's done every year, 73% are aware and currently using BIM in one way or another in their design process, or even their operation and maintenance processes. So we can see how rapid the BIM process has been developing throughout the last decade, and this gives us the opportunity here in the university to include BIM in different projects and in different workshops, just like the workshop that you're taking at the moment. Grasshopper and Dynamo is part of that BIM process, and it can be integrated with other tools to produce a BIM product that can be used later on in construction or fabrication, or can be used in operation and maintenance of the building. So some of the primary tools that are used as a design tool for the BIM process, or having a BIM model. Most probably you've already heard about Revit. So Autodesk Revit is one of the main tools that we use. Around 50% of the market, of the AEC market, uses Revit, either throughout the architecture or structure or MEP the design. And what comes second is the ArchiCAD software, which is from Graphisoft, and it's also gaining popularity here in Australia. we can see around like around 25% of the Australian companies using ArchiCAD, and the rest are using Revit. So those numbers here, those figures are more international figures, which can differ a little bit, or it can give an indication of how Australia is performing also within the BIM industry. So just to recap for what we've been saying, so and to emphasize on the importance of that, BIM is not only a 2D or 3D modeling process. It's not just for visualization. It's more about providing detailed information about how the building will function. And for example, if a certain element is changed in a certain phase of the project, and some information about that element has been changed, it will be coordinated with the other disciplines, and other disciplines will see that change within the model, and will actually, for an example, if an architect decides that this column needs to change for some reason, or they need to place a column elsewhere, the structural engineer will be aware of that, and they can run their analysis again and make sure they update their structural analysis to make sure that the model is safe or the building is safe. So it helps, like the BIM process really helps in the function of the building. And some of the functions that we can get are or we can extract, or some of the information that we can extract from the building, some of the building information model that we have, such as rendering, for example. You can do visualizations, so the client or the users at the end can get a grasp of how their building will look like. You can do quantity takeoff and material takeoff, so you can produce a budgeting report for the building, for example, and make sure that you're you can do value engineering on your building. Then we have different simulations and performance analysis that we can do, such as daylight analysis, for example, energy analysis, and structural analysis, and more types of analysis that we can do through the different engineering disciplines. And one of the important things also is, which is really important within the design phase and the coordination phase, is the collision checking and making sure that your structural engineering is not colliding with your plumbing in such a case here, like in that case that we have right here. Okay, so we can sum up the benefits of BIM through having less time and resources in managing the design process. So we can benefit from having less time to do a BIM model than just the typical 2D modeling way. Of course, a more collaborative approach between the multiple disciplines, as we've been discussing throughout the whole presentation so far. Having less design errors and clashes, since we kind of eliminate some of the human error that comes with coordinating 2D drawings. So we eliminate that types of errors, and having more flexible types of analysis, such as the structural engineering example that I just gave in the previous slide. And more importantly, for both the clients and customers and designers, it will cost less during every phase. So during the design and construction phase, and during the operation and maintenance phase, it will be more economic to use such BIM processes. So the second part of the presentation today is about the relation of sustainability and BIM, and how the BIM process actually improves the sustainability of designing and operating different buildings. So first, let's define what is sustainability in buildings. So it's a place where an owner and the occupants and the ecosystem are satisfied. So it's this middle ground between the different stakeholders of the building. Even the ecosystem is considered as a stakeholder in the sustainable sustainable design, and those can be benefits in terms of environmental benefits, economical benefits, and social and comfort benefits that we can value from or take value from if we're designing sustainably, and those can be through some KPIs or so some values through maybe, for example, their energy consumption, efficiency, utilities management, renewable energy, and strategic management. So all of those processes can help in designing a sustainable building at the end. So sustainability is all about connectedness, and what would be better than the BIM process to apply this connectedness. So we've been talking about how the different disciplines can work together, and how the information is all placed in one model, or in one model, to make sure that the design process is as fluent as possible. So connectedness, as we said, it can be achieved through BIM, and it can accommodate for the different stakeholders and different aspects of the building design process. Oh, sorry. Okay, so for an example, if we're talking about building energy consumption, and I'll be focusing more on building energy consumption, but you can extrapolate that on different aspects in sustainability. So one of the main aspects in building energy consumption is the spaces that we have within our building. So this includes where the spaces are located, their areas, their number of occupants, and maybe the envelope or the materials that we use, and how they're connected to maybe equipments in those spaces, which will somehow affect the energy consumption. And of course, they're connected to the HVAC system, which is by default connected to how those spaces will perform. Of course, the lighting systems. And all of those are, as you can see, are connected together through different processes and throughout different stages. Those processes or those stages connections are emphasized, and we can see those connections and achieve and try to optimize some of the aspects or some of the dots that we have here, in order to achieve a lower energy consumption by testing the different simulation options in the building. So we can say that connectedness help in the anticipation of the building behavior accurately throughout the life cycle of the building. So this is a figure that we've seen through research and through different case studies, that building costs we can decrease building costs by 20% through energy savings using BIM processes. So some of the tools that we use in such process, especially with the energy consumption part and the passive design part. There's a tool called Autodesk Green Building Studio. So it's an Autodesk product just like Revit, so it's connected with Revit. And through this tool, you can start modeling or start doing some simulation or analysis on your building, and try and choose one solution that's high performance solution. And we can test the different scenarios, such as, for example, changing the glazing material of the window. We can change the add more shading or stuff like that. That would give us a figure to see if we're achieving better energy efficiency or not. So this tool is really good, and it's integrated within the Revit Autodesk Revit suite. Another tool which is kind of a competitor to Grasshopper, it's Dynamo for Revit. I'm not sure if you've heard about that before. So Dynamo is kind of like the same idea of, like, it's a visual programming tool just like Grasshopper, but it's mainly targeted for Revit. What we can use it independently, but it's mainly targeted for Revit, and it helps with making sure that the building model that you have is as parametric as possible. And throughout the last years, we've seen a Dynamo being used as a passive design or passive analysis tool for things like daylighting and solar radiation and basic and some of the basic passive design techniques. But however, I guess Dynamo is not as strong as Grasshopper, and that's why McNeil from Rhino have taken the opportunity to create something like Rhino inside Revit, which is it's a development that brings the power of Rhino 7 and Grasshopper within the Revit, within the Autodesk Revit environment. So basically, it's an API that communicates with like Revit communicates with Rhino, and all the meshes and all the objects and information about those objects can be visualized inside of Revit and can be modified inside Revit and Grasshopper and Rhino collaboratively. So this is like, if you don't know a lot about maybe something like Dynamo, you don't like at the moment, you really don't need to learn a lot about it. You can learn about that, or you can learn more about Grasshopper and then use that to use inside of Revit, and which will open the options for many other like simulation analysis and different tools that you can use. Yeah, so those are some kind of like here you can do some radiation analysis and annual daylight simulation using Rhino inside Revit. There are case studies or some examples on the internet that you can find that do that. So coming to the last part of our presentation today are the case studies that actually utilizes BIM to achieve better performing buildings, especially in the area of energy efficiency and passive design. So one of the case studies that I actually worked on was a school building in Saudi Arabia. So this was an intermediate school building that was in a very hot, arid climate, and the client wanted to achieve less energy consumption by changing the materials, by testing different materials for the envelope of the building. So the workflow that we used in that exercise or in that case study was using Autodesk Revit and Green Building Studio. It wasn't a fully parametric workflow, but it was kind of like a semi-parametric workflow because we had to change the test different assemblies and building materials manually. So basically, we had a BIM model, and a BIM model is mainly like the 3D model that we have and all the information that's assigned to it. We had to make sure that we have the right information and extract the right information that we wanted from the BIM model. We didn't want everything inside the BIM model. So, for example, if you have furniture or interior design inside the BIM model, we don't really need a lot of that. And we really were more keen about the external envelope of the building. So we had to make sure that we assign the right thermal data for the materials that we have in the model. Then we converted that BIM model to an energy model, which is an automatic process that happens inside Revit. And then using Green Building Studio, we could test different design cases and different materials and make sure that we, like when we analyze the results, we get the most optimum design through by looking at the cost of the materials that we have and the operation costs and how much savings do we have from that. So we focused on, in this case study, on wall assemblies, roof assemblies, and glazing material. And this is just an example of roof assemblies that we used. We used 5 types, different 5 types. So we used the proposed type, which was the basic type, which was without any insulation. And we tried different thicknesses of insulation, and in order to see which thickness would be more efficient, because of course as you increase the thickness, the price would increase. So we had to do some value engineering in there and make sure that we don't go to the highest option and then it wouldn't be a lot of savings. So we had to do a sensitivity analysis on that. And this is how the results of one of the cases would look like. We have the energy use intensity, and we try to make sure that the energy use within the annual energy use within the building is around certain benchmarks, such as the ASHRAE, for example, ASHRAE 90.1. And we can get how different aspects of the building will perform and the percentages that they use in terms of energy. And taking the example of the roofs, for example, which roof would be better. So we did a life cycle cost analysis and a payback period analysis to make sure that we choose the right material or the right option. So for example, we've gone with type 3 here, which produced around 18% savings in operation and in the operation of the building or operation costs of the building. So the other case study that I have were a little bit straightforward or simple case studies, less detailed, but you can search on a lot of case studies that are regarding passive design. So this was a case study in New Mexico, which they were able to achieve less energy usage by 48% by checking the PV the PV status of the roof and making sure that they optimize where the PV solar panels are going to be added, for example, and they run a little bit of solar radiation analysis inside the spaces to make sure that they lower the solar radiation by changing the glass materials, for example, or adding more shading and stuff like that. So this was another case study. And the third and last case study I have here was a water lab, and this case study remarkably achieved 100% daylight. 100% daylighting throughout the working hours of that lab, so you didn't have to use any electrical energy at that time, while improving, of course, the energy performance of the building by doing that. So yeah, so this is and this building actually was a net zero energy building. So that means it has a net zero usage of energy throughout the year. So yeah, those were the case studies, and this was kind of the end of my presentation. So so if you want to learn more about BIM, or what's the next step in learning more about BIM and going into that world, which is actually what everyone's heading at the moment, or actually they're already there. In the BIM process, like using BIM processes in their different design projects. So one place you can go and learn more about BIM is through LinkedIn Learning. I'm sure the university has a LinkedIn Learning license, and you can please use this license to learn more about BIM. And there is actually a pathway where it's a couple of courses or several courses that it can actually put you on the path of being a BIM coordinator one day. So a BIM coordinator is mostly a person who collaborates with different disciplines and make sure that the building the building information modeling process is efficient. So I always urge people to learn BIM first, then learn Revit. Revit is just a tool that helps you achieve a BIM model, or have a BIM model, or utilize the BIM process. So learn more about BIM, and then go and learn about Revit, and maybe if you want to learn more about Dynamos, or links below, and I'll be sharing those links later on with Todd. Okay, so thank you so much for listening and for sitting through the presentation. And please, if you have any questions, I'm here. I'm happy to answer those.